In this particular YouTube segment, this wraps up our database connectivity topics. But before we go any further, I just want to look at the JDBC.java that we've looked at or worked with. And it does, we know what it does. It does a connection to a database, it does a statement, and executes it. JDBC Enhance, it builds on that logic and lets you do database metadata information from the database. And if you look here, you'll see the code here and here. And I ask you to compare these two, and they work, but what is the issue from an efficiency standpoint? I'll give you a second or two to determine what your response will be. And if you answered that we have the logic repeated in this class and in this class, is not good as redundancy. What happens if I change my JDBC ODBC connection to have a different name? I have to change it in two places. Well, we're going to close this one down because we don't need it anymore, and we're going to close this one down because we're on to a better way. I wrote this particular class when I worked in industry because I was a vice president of software development, and we wrote Java code that could talk to multiple databases, be it Oracle, SQL Server, IBM DB2, and there was some other MySQL, and in a pinch we could do Access even though we didn't want to. So I wrote this one particular class that can be used to talk to any relational database in pretty much the world. And even though it's a couple years old, I found it to be extremely invaluable, and it will be my gift to you to share. It's not a lot of lines of code, yet it's very powerful. So the first thing I'm going to do is turn on the line numbers so we can have some talking points. In this class, you will notice I do some funny comments with the @ sign. And this will come into play a little later on, using the Java doc to build self-documenting web pages. So we import at line 8 the Java SQL. I create a class called DBAccessObject. And you notice at the top of the class I declare 3 objects that are private. And which characteristics of object-oriented design is that? And if you said encapsulation, you're correct, because they're private and only this class can access them. So we have the connection, the statement, and the result set metadata. And the reason I declare them at the class level is because methods down below will be using them. Now let's come down here, and I have 1 constructor, 2 constructors. Remember the 4 rules to having a constructor is it has the same name as the class, which it does. The second is it must be public. The third is it doesn't return anything, and you notice it doesn't say void here or here. And you can't call the constructor anytime you want. You can only call it when you instantiate an object for the first time. So right here, this is what we call the default constructor because it takes no parameters. And right here, back to our exception topics, we can throw the SQL exception and class not found. This particular constructor does not do any error handling. It just says, if I run into a problem, the class that uses this will deal with it. And down here is the second constructor that takes in a URL, and it does throw the same exceptions as the default. This is, in object-oriented design, we know there's 3 characteristics. Encapsulation, which we kind of detailed here, polymorphism, and inheritance. Now I ask you, what characteristic is having two methods with the same name? And if you said polymorphism, you are correct, and that means you're doing great. And if not, well, now you know. The difference between these two is this uses a default ODBC connection name, and this one allows me to pass one in on the when I'm instantiating the object, so I can override the default. It gives me maximum flexibility. You notice they both call the connect to database method, passing in the URL. So let's take a look at it. Its method is private. This method's private. It doesn't return anything, and here's the name, and it takes in SQL, or actually the URL to the database, to the SQL database, and it throws 2 exceptions. So you will notice this class does not handle any exceptions. It just passes the buck back to the helper class that instantiates it. I load at runtime the driver manager. I create the connection using the driver manager based on the URL that was passed in. If the default constructor is called, it does the Java class DSN, and if another URL is passed in, it uses that one. Very easy, nothing more to it. Notice my code is only in one place. It's protected, and that is good object-oriented design. Now let's come down here to get results set. This particular method does return something, and it returns a Java result set object. And you call this method passing in a string which has the SQL statement you wish to execute, and it throws an SQL exception if something goes wrong. I create a temporary result set. I take the SQL that was passed in. I execute the query from the statement object, which was instantiated up here. And then I instantiate it and I return that result set here, and it goes out for people to use. Now I have another method, and you notice it's public result set metadata. It returns back result set metadata, and it's called get result metadata, and it's actually overloaded or polymorphed into the same method with the same name, but this one takes a particular table name. The difference between this one and the difference to this one is this doesn't take in a table. It returns the result metadata for the last execute SQL that was done here. So if I call this and then I immediately call this method, I will get the metadata for this query. If I call this version of the get result metadata method, I pass in a table name, and it returns back the metadata for the table that was passed in. So again, maximum flexibility. This particular class shows polymorphism, the same method with the same name, but taking in different parameters. And this one will, in one statement very efficiently, it takes in the table that was passed and creates a quick SQL statement, executes it on the database, and notice it calls a method nested called get metadata. So execute the SQL, tell me about the columns that make up the SQL statement that just executed, and return it back out for people to use. And we're getting there. We don't really have that much more. We have another method called execute SQL. Now this statement takes in only DML and DDL statements, no select statements. So insert, update, delete, create table, or a drop table. It takes in the statement and just executes it. It doesn't do any parsing for syntax. If something goes wrong, we'll throw back the SQL exception and your code will have to deal with it. So very simple. We return an integer, which is true or false or 0 or 1, depending how many 0 or many of how many rows were affected or if it worked or not. Now I do want to draw to your attention that this table, this particular get result set method, executes a query, and a query means I'm asking the database for information, and it's going to return back a result set that contains from 0 to many records, where this particular method just executes an SQL statement that is a non-select. So basically any other SQL statement: insert, update, delete, create, or drop. Now this method is extremely powerful, and it returns a result set. And what it does is it takes in the table names, and it takes in, I'm sorry, you call it, and it will return back the table that you can find in the database. So when you call this method for the database you connected to, it will, for the connection, get all the metadata for that particular database. So in this case, I'm only asking for tables, so I get all the tables back. And then what I do is I return that back. So you can see very efficient code. And right here, I do a close down. If you have a nice car, you just don't throw into park when you're on the highway. You move to the side of the road and you close it down. Shut down the program, that is, or the car, that is, and then now you're going to shut down your database connection to the statement and then the client. You do it in the reverse of how you instantiated. So we do the statement, then we do the connection, and that's pretty much it. And I do want to stress the metadata methods return back the column names for an SQL statement, and this particular method returns back the database tables. Enjoy. Actually, I ended a little too early. I got to show you how to use this object. So let's compile it. And as expected, I get a clean compile. Let's go to the test. And make note of the different methods that we have in here. Here's the database access object. That's the class. And all my different methods. So here's the name we need to kind of focus on. So let's go over here. And notice I have a try. And the reason I have a try is because all my methods here do not handle exceptions, but throw them back. So over here, I have code to handle any exception that may occur, coding a generic exception handler. So up here, I declare and instantiate two database objects, access objects. One called DBAccess1, DBAccess2. One I call the constructor with a specific URL to connect to, and the other one I let the default. And I have to declare a result set in this code because I'm constantly asking the database object for result sets. So right here, I say, get me the result set for this particular SQL statement, and I put it here, and I put the information out to the screen. Notice I do the get result set. And in this one, I do execute SQL. This is I'm doing a DML or DDL statement. So I'm doing an insert, and notice I have to call the execute SQL, not the get result set. And I do an update, and I do a delete. And down here, I decide to ask the database to find out about what tables can be found within that database. So I call the get database table names, and it returns it into a result set, and I process it. Then I decide I want to get the result set for the last SQL statement. Notice I don't pass in anything, so it gives me the last statement that executed, and it gets me the columns for that, and I process them. And notice I have to have a result set metadata. So up here, I was able to get a result set. Here I'm getting the metadata because I'm asking about table information. And down here, instead of going with the one that was last executed, I'm asking for the metadata for a particular table, and I process it, and I close it down. And we are ready to rock. Let's let this go. Clean compile. We're running it, and there we go. And let's compare what we have here. Let me move that down and go up. So this code, or this output right here, is related to this code here. The insert, update, and deleted is insert, update, and deleted. And notice I asked for the tables in the database. That's this code right here. Now, step number 5, did I? Yes, right here I asked for the column information. Is that correct? Yes, I asked for the column information for the last executed SQL. And the last executed SQL was this one, so it gives me these columns. And you notice right here I asked for the columns to the employee address, which is these columns. So you can see simple yet very powerful. And now I'm done.